with current electricity today. So we'll start with the basics of theory of it. Now see class, from this current electricity, the circuits part, we'll have a separate class for it. So it's Sunday, no? So on Tuesday, we'll be having the class for it. All right. So yes, now in electric current is what? Electric current is basically rate of flow of charges. How the charges flow. Whenever anything gets divided by distance, I have been mentioning this in our regular classes as well, that when anything gets changed with respect to position, right, we say it is gradient. Like you have E is equal to minus dV by dr. That is change in electric field with respect to distance, right? So that is gradient. Whenever anything gets divided by time or changes with respect to time, we say that it is rate. So rate of change of something, right, is when a quantity is getting changed with respect to time, right, in equal intervals or in unequal intervals, that is not defined. So similarly here also, electric charge we have been studying in electric current, right? But as soon as these charges get changes, begin their motion and change with respect to time, whatever they cover a certain distance with a certain amount of time, we call it as electric current. So rate of flow of charges is electric current. So direction of current, for positive charges, whatever is the motion of it, it will be same. Negative charges, reverse it, especially for electrons and all. Electrons will be mentioned in the questions. So reverse the direction, right? Yes, then if you have a particular duration, like from this time to this time interval, you have to find out the current, or a specific time is given. Let's say 0.005 seconds. There is a difference between these two, right? When there is a duration, that is, it has a starting, it has an ending. From 4 p.m. to 7 p.m. From 0.2 seconds to 0.9 seconds, like this, you have a particular duration. So that is average current. That time you will calculate average current. You will take the difference of the initial and final charges, right? Whatever is the charge difference, divided by the time difference as well. Final time minus initial time, that also. But if a particular instant is given to you, let's say 0.007 seconds or 0.0089 seconds, like this, you have a particular time instance where you have to find out current exactly at that particular moment. Then you will perform differentiation. Find rate of change of charge, you will calculate dq over dt. I'll show you. See, this is how you calculate average current, and this is how you calculate instantaneous current, dq over dt. Simply differentiate it. So current, though it has a direction, this is the only quantity that is scalar but with direction. Reason behind is that it does not obey the vector laws. For a quantity to have a direction, magnitude, and as well as it has to have a specific direction, then only it will specify it. All right. So this is a scalar quantity because it has direction, it has magnitude, but it does not obey the vector laws which we have parallelogram law. So you don't need to, though you are having a direction over here, but you don't need to calculate in terms of direction. Directly add it, subtract it. Positive, so add it. Negative, so subtract it. And SI unit is amperes. So this is 1 coulomb divided by 1 second. 1 coulomb per second, this is amperes. This can also be related when one time period, you can write it as frequency. This part, 1 by time period is basically frequency. So 1 over time period, you can write this as frequency. So that becomes charge multiplied by frequency. This also becomes one of the formulas for it. Then basic graph part, slope of QT graph gives you current. Fine, take out the slope. Slope you can calculate by tan theta. That will give you the current. Then next quantity which you have is known as drift velocity. So what is meant by drift velocity? In drift velocity, basically, you have so many electrons, you have so many positive charges, right? So many negative ions, positive ions, electrons, all are present within the conductor. So what happens when the electrons begin their motion under application of electric field? Every electron will be having its own unique velocity. One electron will be moving with some velocity, other electron will be moving with some other velocity. the third one will be moving with some velocity. So likewise, all the electrons will be moving with their independent velocities. But when I'll ask you what is the velocity of the conductor, so what will you reply? Will you tell me the electron of the first one, second one's velocity, third's velocity, which one? It's not possible, right? Even in a batch of students, if someone asks me what is the score of the student, so will I give Krishna's score, Marita's score, or Adriel's score like this? This is not possible. So what do? We take the average of all the velocities that are executed by each individual electron, and that average velocity with which the electrons are actually moving, they are drifting from one terminal, negative terminal, towards the positive terminal. This is basically known as drift velocity. So here the derivation part is not needed now. You just have to remember this formula. Vd is equal to minus E tau by m. Small e is the electronic charge, 1.6 into 10 to the power minus 19. Capital E is the electric field. Tau is the relaxation time. Relaxation time, that too average relaxation time. What is average relaxation time? See, when two electrons, they are colliding with each other. Let's say the two electrons, they have collided. Now, once they have collided, now they'll begin and collide with another electron. So in between this interval, no, when the electron rests, it is not colliding with any of the electron. This interval, very, very small interval, this we call it as the relaxation time. So every electron will be having its own relaxation time. So how do we find out the conclusion for a conductor? We take the average of it. So average relaxation time is basically average of all the relaxation time exhibited by individual electrons. And then m is mass of electron, 9.1 into 10 to the power minus 31 kgs. This also you should remember. Negative side. Here we do put a negative sign. This, I think, negatives. One more thing before this negative sign. Temperature, tau, and drift velocity all are connected to each other. Fine. Temperature, tau, drift velocity, all of these three are connected to each other. So if you decrease the temperature, if you increase the temperature, that will affect your relaxation time. And if relaxation time is affected, then it will affect your drift velocity as well. So if your temperature is decreasing, tau is inversely proportional to temperature. If temperature is decreasing, tau will increase. And when tau, that is relaxation time, increases, drift velocity also increases. So there's an increase in it. Now see, we are taking this formula F is equal to QE. And here we are continuously talking about electrons only, right? The elementary particles which are under consideration are the electrons. So F is equal to minus EE, that is QE, using this formula. That's why we keep the negative sign at the end. But if you take out the magnitude, you can easily eliminate this negative sign. That depends upon the option which is given to you. Yes, this relation, just remember I is equal to NEAVD. Now this relation, no, for your JEE, from your JEE perspective, whichever quantity is missing, like suppose drift velocity is missing, current is given, so you can use this and relate it directly. Questions aren't used from this part. I is equal to NED. So this is not so very important. VD, yes, current is independent of area of cross section. What is the formula? Formula is I is equal to NEA VD, right? So from here you can see current and drift velocity both are directly proportional to each other, but this isn't the case. Though it appears that both are directly proportional to each other, but when you will notice that even whatever is the amount of current that is entering from a junction, that will only leave it right from the other end. So amount of charge that has entered is equal to amount of charge that has left. And what is current? Current is basically rate of flow of charges. So this remains, at least this part remains the same. Fine, this is independent of drift velocity. But when we are talking about cross-sectional area, you can see drift velocity will be I by NEA. So drift velocity and area, they are inversely proportional to each other. So this is true. Wherever the area is narrower, the electrons will rush with a greater velocity, right? And where the area is wider, the electrons will rush slowly. That determines its speed. So this is not important from your numericals part, but from your theory part, which is asked. Ohm's law basically says that temperature, pressure, if they do not change, if these quantities do not change, potential is directly proportional to the current. And a quantity you get, which is a constant, is resistance, right? Now, graphs, just remember one thing about the graph. The graphs are very easy. From current, electricity, even the graphs that have come in your exams, they are also very easy. It's just that, class, you have to pay attention whether it's V versus I graph or I versus V graph. Because when it is V versus I graph, and both the options will be there, both the correct answers will be there in the option, and that will be confusing. V versus I graph is there. Slope, tan theta you will calculate. That will give you the resistance, right? But when it is I versus R, when it is I versus V, the slope, tan theta, now this will be 1 by R, because quantities have reversed. I by V is not R. I by V is 1 by R. So that reverses it. So be careful whether you are calculating 1 by R or R using the graphs. Fine, because this can be a little tricky, because you will just see the ratio and both the options will be mentioned. This is it. Then resistance and resistivity, some important terms are here as well. Resistance I've told you, and resistance, this formula you should just see. ml divided by ne square a tau. What is m? Mass of electrons. L is length of conductor. N is number of electrons, number density basically. E is again the electronic charge, 1.6 into 10 to the power minus 19. A is the cross-sectional area, not the area of the conductor. Fine, this A sometimes becomes confusing when area of the conductor, because length is already mentioned. So it becomes confusing whether you should calculate the area or not. So this is the area of the cross section, pi r square. That is for circular cross section wire, it will be pi r square. If it is a square shaped wire, then a square. The way you calculate simple areas. Tau is the average relaxation. This formula is important. V is equal to IR, this formula. And one more formula you have for resistance is rho L by A. Whichever is suitable, apply it and see. Now, from this, rho is resistivity, L is length, and A is area again. So resistivity is resistivity depends upon the material. Resistance doesn't depend upon the material. Even if you, it's like for the resistivity of brass is defined, the resistivity of zinc is defined. So if you change the material, resistivity will change. But even if you take a very small section of it, resistance won't be affected, because it is independent of all these quantities. Resistance doesn't depend upon the material. Resistance depends, resistance and resistivity, both of them, they'll be changed upon the whichever material you are using. But yes, one more thing regarding resistivity is that it is independent of length and cross-sectional area, which was mentioned in resistance. Resistance depends upon all these things: length, area, just nature of material, and temperature. But resistivity does not have these two quantities, length and area. Fine. Then there's a difference in the SI unit, ohm meter, and SI unit of resistance is simply ohms. Yes, then these two quantities, conductance and conductivity. See, resistance is R, ohms is the SI unit of it. Just reverse it. 1 by R, that will become your conductance, and ohm inverse will become your SI unit for conductance. And same way, the way you have resistivity, inverse of resistivity will become conductivity, and same way, the SI unit was ohm meter, so this will become 1 by ohm meter, or ohm meter inverse. That is conductivity. So these formula you should remember. Yes, current density is important. J is equal to I by A. This is current per unit area. Whatever amount of current is flowing and is changing with respect to area. So SI unit, this is amperes, this is meter square. So the complete area, this becomes ampere per meter square, and it's a vector quantity. Whatever direction of current you're taking, you should take it same for the current density. J is equal to sigma E. From here you have J as the current density. Sigma is again the conductivity. Just now we have seen in the inverse reciprocal of resistivity, same thing. And E is electric field. This is also known as microscopic form of Ohm's law. If anywhere this is mentioned, microscopic form of Ohm's law, use this relation, J is equal to sigma E. Then mobility means drift velocity per unit electric field. The ratio of drift velocity and electric field, this is known as mobility. So pay attention to its SI unit because sometimes it is difficult to identify mobility in the question. So what you can do directly by putting and placing the SI units, you can check and see. From these graphs are more important in your semiconductors, but you can have a look if you are considering conductors. So for conductors, temperature increases and resistance increases. So firstly it is non-linear, then the graph becomes linear. At till 273 Kelvin or 0 degrees Celsius, the graph is almost non-linear. Then it becomes linear after 0 degrees. For alloy, same thing. As you will be increasing temperature, you will be having the resistance and resistivity also increase. But just the difference is that here the variation is very small. You will see a slight inclination in the graph. You can see if this was the reference x-axis, this much only increment has occurred. Then semiconductors, if temperature increases, then resistance or resistivity, this decreases. So you will get a proper hyperbolic graph, inversely proportional graph. So this is basically a summary you should remember. And whatever is the case for insulators, same is the case for semiconductors. Both of them have the same case. Superconductors you should remember, because if the graph is given, identification of graph can be given. All the 4 graphs, 5 graphs, every graph will be mentioned to you, and you have to choose which graph is depicting which material: conductors, insulators, superconductors, alloys. All right. And this finally, this formula you should remember, RT, that means resistance at room temperature is R naught. Resistance at any temperature is R naught, that is resistance at room temperature. 1 plus alpha. Alpha is coefficient of resistivity. T minus T naught. T is the temperature which we are calculating, and T naught is the room temperature. So instead of writing T minus T naught every time, you can use delta T, that is the difference between the actual temperature and room temperature. This formula is used in, especially it gets related to your heating electric effect. Heating effect of electric current. No, you have questions on toasters and coils. So there, this concept is used. Lastly, that we'll discuss in the theory part for today is terminal potential difference, EMF, right? Now see, terminal potential difference, before we start with that, internal resistance you should remember. So resistance we have been studying right now, only we have discussed. But see, when the circuit is connected, it is connected to the cells as well. So under the cells, you have electrodes. Within the electrodes, the electrodes are dipped into the electrolytic solution. So what happens? Whatever is the resistance that is offered by the electrodes and the electrolytic solution, we call that as the internal resistance. Because we have not placed or put that resistor in our circuit, right? That was already present. This internal resistance is already the resistance that is offered by the circuit. This is, we haven't put it. So that is known as internal resistance. Then you, the internal resistance, after internal resistance, you should remember EMF. But EMF and terminal potential difference, they go hand in hand. Whatever is the maximum potential difference that is applied across the terminals for open circuit, we call it as electromotive force. And it's a misnomer. This is not a force, electromotive force. This is basically potential difference. So potential, you can remember this in the manner that potential difference that is offered by the electrolytic cell. That is offered by the electrolytic cell. This is known as EMF, and which is provided by the external resistor. Whatever is the terminal potential difference that is provided by the external resistor, that you call it as the terminal potential difference. So external resistor related with terminal potential difference, internal resistor related with your EMF. So these are some formula that you should remember. That's it. We'll now start at least with the numericals. Some numericals we should do. So current is E divided by R plus R. R is the external resistor, small r is internal resistor. The resistor that is already present. So if you are asked to calculate the potential difference between the across the external resistor is mentioned, and current you know, so simply I into R. And suppose even if you know the internal resistance of a cell is R and current is I, and you are asked to calculate the potential difference, so use IR. That is also fine. Use IR. And then this formula V is equal to E minus IR. From here you can put I as E by R plus R as well. All right, let's begin with the question part. Whatever doubts you have, you can ask me. And again, same thing. First note down the question. When question is written, try it yourself and we'll discuss it. All right, I am discussing it. Only Marita has given the correct answer. What about others? See, here it says that let's take some side. Let's say this is A. Side of the square is A. Because we have a square over here. Then it is each side is bent to form a complete circle. So now a circle has been made. It means 2 pi r is actually equal to 4 times A. This is now bent in the form of circle. So whatever is its periphery is exactly equal to whatever is its periphery. So from here you can at least say that 2a by pi is the radius. Now see, resistance of each side. If the resistance of each side of square is given to you, that is 3 ohm. So what will be total resistance? 4 into 3, that is 12 ohms. This will be the total resistance, right? So for resistance, so if this is for R, then for 2 pi R, how much it will? This is 12 ohm. For 2 pi R, this is 12 ohm. So now for pi R, this becomes 6 ohm. So it means why pi R? Because we need this part of semicircle and this part of semicircle. This is 6 ohms and this is also 6 ohms. So they are connected. They are equivalent resistance. You have to find out they are now in parallel. So equivalent resistance will be 6 by 2, that is 3 Okay, I'll discuss it. So Priya Darshini and Marita have answered it correctly. Look here, class. What will be the equivalent resistance? 2 kilo ohm here, 2 kilo ohm here, 2 kilo ohm here. Right? So in steady states, capacitor will act as an open circuit. So you will calculate equivalent resistance, that is 2 plus 2 plus 2 times the kilo ohm. That becomes 6 kilo ohms, right? So what is the value of current? Potential divided by equivalent resistance. Yes, Adriel, right. Good. So potential is 6 volt. This is 6,000. That becomes 1,000 in the numerator. That is 10 to the power minus 3 amperes. So what is voltage across 2 kilo ohms? Right. So just multiply it, current, multiply the current by the voltage, you'll get it. By the resistance, you will get it 10 to the power minus 3 into 2 kilo ohms. So 1000 or 10 to the power 3, directly 1000 and 10 to the power 3, they'll get cancelled. You will have 2 volt here. Now you finally have voltage which you have to use, and you have capacitance. You have to find out charge. Q is equal to CV. Capacitance is 50 microfarad. So micro has been converted. Voltage is 2. So 100, 10 to the power 2. So 100, it will become micro. This is micro, no? So 100 micro coulomb, because unit was given. So 100 is the answer that you had to write. Note it down quickly. One more question I'm giving. One easy question let's do based on color coding, because that is also coming. Last 2 years consecutively questions on color coding from current electricity have been coming. Yes, class. Apart from Marita. See, for violet, red, green, let me write this. Violet you have green, what else? Red is there and gold. Gold, so you have for percentage purpose mainly. See here, violet is 7, green is 5, red is 2, and golden is 5%. Gold and silver, you must be remembering it. This is the first one, second, third, fourth. These are the colors that are given: violet, green, red. So resistor, how do you write the first one? First two, they will be 75. This will write to, you will write it together. This will become the power of 10. So 10 to the power 2 plus minus 5%. Fine, this is plus minus 5%. So 7500, you have it from here. 7500. Fine. So two options at least you get eliminated. You can eliminate 750, 70 A and B and D. Now see, out of these 5% of this, if you will calculate, what will it be? 5%, you have to find it out for 7500. D, it will become, yes, 375. Right, Krishna. So it will be, this is how much? 75 says 375. So 5% of, if you will calculate 7500, that will give you 375. This is how you will determine it. Otherwise, like Marita, you were also getting B options. Because of this, it can differ. So depending upon gold or silver, you can calculate that. Yes, most of you have given correct answers. Krishna is right, Adriel, Merita. Yes, all of you are correct. See, you will just use, this is a formula based question only. RT, this formula that we just discussed, RT is equal to R naught 1 plus alpha delta T. This is what you're going to use. So see, for the first one, that is 16 and 15 degrees. So this will become 16 is equal to R naught 1 plus alpha 15 minus T naught. And second one is 20 and 100. So this will become 20 is equal to R naught 1 plus alpha 100 minus T naught. So we have put in everything in this formula. Now they just take the ratio. Take the ratio, divide both of these. Just take the ratio, divide it. So that becomes 4 by, the resistance will also get cancelled. So 1 plus 15 alpha. Because see, general T naught is not mentioned, no? The room temperature is given. Resistance for temperature of question. When this is not given, no, according to the convention, what you can take T naught, you have to take it as 0 degrees Celsius by convention when it is not mentioned. By default, just take it as 0 degree if it is not mentioned. Like in this question is also it is not mentioned. So that will become 15 alpha divided by 1 plus 100 alpha. So simple cross multiplication now, 4 plus 400 alpha. 5 into 1, 5 plus 15 into 5, 75 alpha. How much? 400 minus 45 this side and 5 minus 4. So 325 is equal to 325 alpha is 1. Alpha will be 1 by 325. What is 1 by 325? This will be 0.003. 0.003 degrees Celsius inverse. So C option, yes. So those who have answered C option, their answer is correct. So only Krishna's answer is correct. Rest of you must have committed some error. See, let's say resistance, take iron wire's resistance as R1. Take this as R2. Now see what will be resistivity. This is given as 12 micro ohm. Adriel is also correct. Ohm centimeters, that is 12 into 10 to the power minus 8 ohm meter. Same way, resistivity 2. This was 51 micro. That will become 51 into 10 to the power minus 8, not 18. Minus 8 ohm meter. So for parallel combination, R equivalent becomes what? R1, R2 by R1 plus R2. And you know R is rho L by A. A also you can write it as rho L by pi, R1 square. Right, this much you can do. Now see, same thing I'll write over here as well. So rho 1 L by pi R1 square, this is R1 plus rho 2 L by pi R2 square, R2 divided by rho L by pi R1 square plus rho 2, this is rho 1. L by pi R2 square, this is 3. Equivalent resistance is given to you 3. Now see pi and L, they'll get cancelled only. Pi and L from everywhere, they'll be cancelled. What all things are mentioned? Diameter is 2, no? So that becomes 1 mm. So if you square it, that becomes 10 to the power minus 6, right? See, 2 mm is the diameter. So radii will be 1 mm. 10 to the power minus 3. So r square will become 10 to the power minus 6. So if you put in all the values, this is 3. So that rho 1 is 12 into 10 to the power minus 8 divided by 10 to the power minus 6. Pi and L will be cancelled into 5 into 10 to the power minus 8 by 10 to the power minus 6 divided by same thing, 12 into 10 to the power minus 8 by 10 to the power minus 6 plus 51 into 10 to the power minus 8 by 10 to the power minus 6. So when you solve this, okay, L will remain. L won't be cancelled. 1 L will cancel, 1 L will be remaining. Right? So same way with pi also. So let me write, this is pi, here also pi will come. And 1 L will remain. So let me write L. So when you solve this equation, this will be 97 meter, which is option B correctly. Note it down.